All right, we have some homework due today. Are there any questions about the homework? I think it was just one set of exercises to do some textual substitution with quantification. So I think it probably wasn't too difficult. But any questions about the homework?
No, it was easy.
That's what I thought.
It was really short, too.
It was short and easy. Short and easy.
Great.
Short and sweet. All right, we have a lot to do today, okay? So let's get started. What we're going to do is we are going to illustrate, we're going to start our axioms and theorems for general quantification. Okay, so these are the general laws of quantification. So here's the section in your equation sheet. And in all of these expressions, star is a general binary infix operator with what three properties? What is that star? It is a what? Starts with an A? No, no, the star. No. What's it called?
Like guys.
I am an.
Oh, it's an abelian monoid.
It's an abelian monoid. And what are the three? Star, so star is an abelian monoid, and what three properties does an abelian monoid have? First, it is. Well, it's symmetric.
Symmetric.
Okay, which means no, not transitive. Symmetric. What's the second one? Somebody said it actually. No. Associative. Yeah, that's the second one. So it's symmetric, associative, and what's the third one?
Cool.
It has an identity. Now, a lot of the examples that we're going to do today are going to be with plus, and we know that plus is we know that addition is an abelian monoid because it has all those three things.
I have a question on the
And-
homework, actually.
Oh, you do? Now you have a question on the homework. Okay,
Right.
we'll take a break here.
All right, for E,
Yes?
it has like one quantification inside another quantification.
Yeah, you can have nested
And-
quantifications,
But
yeah.
The textual substitution is on one of the variables in the range of the first quantification, but not in the second one.
Then you have to,
Except it plugs in something that is in the dummy of the second one. Do you have to do dummy replacement on the second one?
well, to be safe, what I would do is you could do dummy replacement on both.
Yeah, well, you don't need to do it on the first one at all.
Oh, okay, well, then what's your question?
Well, do you need to do it on the second one? If
Okay, so,
I'm gonna just read his problem.
sure.
Alright. Parentheses, star, X, funny looking line thing,
Okay, the way we say this is range.
range.
Okay, so you say quantify over X, range what?
0 less than or equal to X less than
R,
Yep.
lowercase r?
Translation.
And the way how do you say that? No, how do you say
That's
this?
a colon.
No, you say body.
Colon.
The way that when we say this, we say range,
Body.
this, body, what?
Parentheses, star Y,
Star Y, range.
0 less than or equal to Y, body X plus Y plus N.
Body X plus Y plus N.
Double parentheses.
Yes. Textual substitution.
R replaced by Y. Do you need to do dummy replacement on Y before you put an R, or is it?
You absolutely have to do dummy
Okay, so-
dummy
so
dummy
when
renaming. This is called dummy renaming
Whatever it
of
is.
this one.
When you know how it says provided that not occurs R or Y in the quantification.
Yeah, but
it means all of the quantifications.
Yes.
Including all
Yes.
ones that are inside of it.
Yes.
Got it. Thank you.
So the answer is because this Y occurs here, you've got to do dummy renaming here before you do the textual substitution.
Yeah. This textual substitution applies to the whole thing.
Yes, the textual substitution applies to the whole thing.
Sick.
Good? Are we good?
Cool.
Okay. Now that we have all the questions from the homework answered, let's start going through our list of axioms. Now, what I'm going to do is, with these general axioms, I want to give examples. So we're not proving these, or we're giving examples because I want you to, we need to understand,
We can't prove them.
we can't prove them because they are axioms. But we need to understand what they're saying, all right? So first we'll start with 8.13. Which is an axiom called empty range. Now, I want to illustrate this as follows. Check this out. Suppose we do sum over I, range 2 less than or equal to I less than 4. 2 less than or equal to I less than 4. Body I squared. Okay, Kyle, expand this out for us. If we were to write out the terms, expand this out, what would you get?
All right, 2 squared plus 3 squared. That's it.
And that's it. Is everybody good? All right, Kale, sum over I, 2 less than or equal to I less than 3, body I squared.
I haven't watched the lecture.
Okay. Mason,
So I'm in those. It's gonna be
this is sum over I, 2 less than or equal to I less than 3 I. So what are the possible values of I?
gonna be like
2.
2
2 what?
squared.
So this would be 2 squared.
That's it.
And that's it. Is everybody clear?
Yeah.
Can you kind of see what's going on here? Okay. Now, Rochelle, what do you think? What if we did plus over I, 2 less than or equal to I less than 2 I squared? Well, I mean, because you know, yeah. What are the possible values of I here? What are the possible values of I? What possible values can I take, assuming that I is an integer? What possible values of I did we have here? We had I could be 2 and I could be 3. What could I be here? It could only be 2. What can I be here? It can't be anything. So actually, do you see then that 2, in fact, what does 2 less than or equal to I less than 2 mean? It has conjunctive meaning. Josh, what's the conjunctive meaning of 2 less than or equal to I less than 2? I'm asking because I know you are.
2
is less than
or equal to
I.
And
I is less than 2. So is that expression, what do you know about that expression?
It's
2,
false.
it's false. So this is, because it's impossible for 2 to be less than or equal to I and I to be less than 2, right?
yeah.
So this is the sum, this is plus I, false, I squared. Are you with me?
Yeah.
But what does axiom empty range, see, when you have false here, what is that range? When we have false here, we say that is the what?
Empty range.
That's the empty range. And what does this say, the empty, what does it say?
It equals U.
It equals U. But what does it say U is?
An identity.
It says for symmetric and associative binary operator star with identity U. So therefore, but what's the identity for addition? Rochelle, what's the identity for addition? You know, you remember? The identity, 0. So what does this equal?
0.
0.
Sick.
Are you with me? Is everybody clear on this? Tell me this. What is the product over I? 2 less than or equal to I less than 2 of I squared. What's that?
1.
That's 1. Is everybody clear? Because why? Because 1 is the what? Identity for the multiplication. Does everybody see that? Okay. That's an example of 8.13. How about 8.14? 8.14 is called the axiom 1-point rule. Now let me ask you this. what is the sum over I range I equals 3 body I squared? Kyle, what's the...
3 squared.
Yeah, that's 3 squared. Now, what does the 1 point rule? The 1 point rule applies when there is a what in the range, when the range is of what form?
Not occurs xe.
Well, provided that x is not in E.
Right.
What, I mean, see, because 3 is not in I, right?
Sure.
I mean, but it's of what form? What is the form of the range? X equals an expression. Are you with me? So it's anytime this equals, do you understand that if you have something like this, we have a whole bunch of different values of I. I could be, here I could be 2, I could be 3,
Sure.
right? Whenever you have an equals, you're just talking about what? One value. You're talking about 1 point. Is everybody clear on that?
Yeah.
So if you're talking about 1 point, what does it say? It says it's P with X replaced by E. Well, what is our P here? Here our P is, this is the body, right? So do you see that this is the body I squared with I replaced by 3. See? It's the same, that's what it is. Makes sense, yeah? Yeah, that's what we want to do. We want to understand how all of these axioms make sense. Right? This one makes sense. Well, I mean, you might, when it's false, you know, you use the identity for whatever the operator is. Yeah? And if it's 1 point, all you need to do is you take this and you do this replaced by this in this expression. Textual substitution. So that's empty range and 1 point rule. Okay? Now, the next one we want to illustrate is axiom distributivity. And I'm going to do this by an addition. So this is example 8.15, distributivity. Okay? Now, what does this distributivity say? This is kind of has sort of an interesting format. What we have on the left side of the equals are 2 quantifications, right? And what do you know about their ranges?
They're the same.
They're the same, right? This range has the same thing. Actually, both of these quantifications are exactly identical except for which parts?
The body.
The bodies. Okay? But they have the same range. So what this says is that if you have, and not only that, but this thing that we're quantifying over is star, right? And that's the same star as this one. So if you have a quantification over some operation with a range, and then you have that same operation, and then you have a quantification with the same range of something else, what does this say you can do? It says this is the same as what? 1 quantification over that range,
Okay.
but the body is the first star of the second. Okay? Now, why is that? Does everybody see the structure of you know what that structure is? So check this out. It's obvious why this is so. Look at this example. Suppose we do plus I. Let's do 1 less than or equal to I less than 4, body 2I, and then plus. So here's a plus and here's a plus, and let's do the same. Plus over I, same range, 1 less than or equal to I, less than 4, body, let's say 5I squared.
Can we use multiplication?
Let's do plus. We could do multiply all the way through, but let's just do plus. But if we do multiply here, we have to do multiply here, and we have to do multiply here. It would still.
It has to be the same operator.
It has to be the same operator. Okay, so it would work but same one everywhere. Okay, so now, Mason, let's expand. Yeah, let's write this out. What is the sum over I, range 1 less than or equal to I less than 4, body 2 times I? What is that? Well, what are the possible values of I? What are the possible values of I?
1, 2, and
1, 2, and 3. So it's this with I being 1, 2, and 3, right? So what is it?
So 2 plus.
Wait, 2 times what?
2 times 1.
1
Plus 2 times 2
plus 2 times 2 plus 2 times 3. Okay, is that, you got that? And then Rochelle, if you multiply, not multiply, if you expand this out, what do you get? And then this plus is here, right? And what?
5 times 1 squared.
Say it again.
5 times 1 squared.
5 times 1 squared.
Plus 5 times 2 squared.
5 times 2 squared plus 5 times 3 squared. Now we know that this is symmetric, right? Because it's an abelian monoid, right? So by symmetry, Josh, what do you think in order to do this, in order to get this into this form, what should we group together? How should we, symmetry means we can move these around in any order, right? So how should we move them around to get them in an order to where we'll get the right-hand side of our thing there? Well, look, this says that it's
right.
okay. So how should we manipulate this? You see where we're headed?
Sure. Simplify
Two-
the twos.
Yeah. Well, do you agree that this is 2 times 1 plus 5 times 1 squared? Okay, yeah, here, it's this one plus this one, plus, it's this plus this, plus what? Plus 2 times 2 plus 5 times 2 squared. Are you with me? Plus 2 times 3 plus 5 times 3 squared, right? That's just by symmetry and putting in some parentheses. But now how would you quantify, so now how do you quantify this? This is, what is this equal to? This equal, let's put quantifying. Kyle, what do you think? Quantifying. Can you go the other way now? And can you write this? Can you write this as a quantification?
Yes. Yeah, okay.
So what would this be?
Star,
Yeah, in this case it's plus.
or yeah, plus
Oops.
I,
Plus over I,
range,
range.
oh yeah, 1 is less than or equal to I is less than 4.
Yeah, now body what? 2 times 1 plus 5 times 1 squared. 2 times 2 plus, yeah.
5I squared.
2 times I plus 5 times I squared. And you see, isn't this an example of this? Are you with me? So do you see how that makes sense? But it depends on the fact that it's symmetric. We have to be able to move these over like this around. Are you with me? Does everybody see how, does that example make sense? Okay. Now this next one is called axiom range split. Okay. And the range split works like this. It says provided, oh holy cow, what is this?
Can you explain all the provisos? Why does that last one have to be like a Boolean or R is finite?
Yeah,
Why can R not be infinite?
let me postpone the answer to that question. You're impatient. I think you'll see after I do we'll do a few more examples and I think you'll see. Okay?
Sure.
So let's do example 8.15. Example 8.15. Oh, sorry, 8.16. We just did 15.
We're like married.
Now, let's take a look at what this says. It says provided. In fact, here I'm going to give you an example right now. provided R and S equivals false. I'm going to give you an R, and I'll give you an R, and I'll give you an S. Here's an R, and our R is going to be 0 less than or equal to I less than 3. R equivals 0 less than or equal to I less than 3. And S is going to be 6 less than or equal to I less than 9. Now, let's calculate both R and S. So R and S, and let's calculate R or S. Now, what is R and S?
False.
Actually, let's just calculate R and S.
False.
Yeah, R and S is 0 less than or equal to I less than 3, and 6 is less than or equal to I is less than 9. Right? But what is that?
I have no idea.
That's false.
If it were an or.
Yeah, this is false. Does everybody see why this is false? Because if 0 is less than or equal to I is less than 3, then the possible values for I here are what? What are the possible values of I for just this one? 0, 1, and 2. It's saying this is saying I has to be 0, 1, or 2. This is saying I has to be what?
6, 7, or 8.
6, 7, or 8
Same time.
at the same time. It can't be. So R and S is false. Is everybody clear on that?
Sick.
Okay.
No.
So let's start with, here, I'll tell you what let's do. Let's start with the left-hand side. Let's start with the left-hand side. It's range split, okay? So let's do plus over I, and I don't want to keep writing R and S out, so I'm just going to use, this is R and this is S, okay? So sum over I, R or S, body I squared. Okay? So this equals, I'll do the first one here, definition of RS. Well, I will go ahead and write it out. Plus I, 0 less than or equal to I less than 3, or 6 less than or equal to I less than 9, body I squared. Okay? Now it's time to expand. Hmm? No, this is an example. We're not proving. No. It's an example. Okay? I'm trying to convince you why it's reasonable. Okay? So let's expand. Okay, have you seen enough of these examples to know what we're doing here? Could you expand this out? What do you think, Mason? What is I is less than or equal to I is less than 3, or 6 is less. So what are the possible values of I here?
Possible values are 0, 1,
And 2,
and 6, 7,
8. So what is it? It's so it's over I, and it's I squared. The body is I squared. 0 squared
plus 1 squared,
plus 1 squared plus 2 squared plus
no, isn't it 4?
Oh,
Or no, we add allow. So
Plu-
it's plus 6 squared,
plus 6 squared
plus 7 squared,
plus 7 squared plus 9 squared, right?
not 8 squared. 8 squared.
No 9 squared.
Sorry.
Hey,
Okay, so now Rochelle, can you write this? Can you quantify, how would you write? How would you write this?
Just two separate ones.
Yeah, how would you quantify this? How would you write, let's quantify.
Plus I,
Yeah, okay, so sum over I, range what?
range 0, or equal 0,
0
great.
less than or equal to I less than 3 of what? Body what? Body what?
And adjustments up there, like 1 squared plus 2 squared.
Well, what do we have? My question is, what do we have to put in the body for this whole thing to expand out to this? What do we?
I squared.
Yes, I squared. And then plus, and then what about this one?
So my range, greater than or equal to 6, less than
6 less than or equal to
less than 9.
I less than 9. Body what? Body what? Yeah, right. I squared. Body I squared. But you know, this, you know, by our definition of R and S is sum on I, R, I squared, plus sum on I, S, I squared. All right? And this is an example. So does that make sense? You see how range split works? Because R and, you know, if R and, because R and S has to be false.
Has to be. Because if it was true.
Actually, if it's true, if it's true, what case do we have? Instead of doing 8, was this 816?
You have 18?
We have 817.
Oh.
Yeah? What's the difference between 16 and 17? What's the difference between 16 and 17? What do we have with 817? We had, no, look. The difference between 16, what's the difference between 16 and 17? 17 says, with 16, R and S has to be false. With 17, no such restriction.
Yeah, except you have...
Except that you have this little extra
Okay.
R or S, R and...
18.
Well, yeah, 18 is for idempotent. Yeah, we'll do idempotent in a minute. But what about what's the difference between 16 and 17? We have this little extra thing on the left-hand side. Why do we have this little extra thing on the right-hand side? Because R and S is not false. Now here is how that works. I think this is, so here's an example, 817 range split. Example 8.17 range split. Now check this out. I think this is really illustrative of what's going on. So let's say now R and S is not required to be false. R and S is not required to be false. Okay, so here's an example. Suppose R equivales 1 is less than or equal to I is less than 5. And S equivales 3 is less than or equal to I is less than 7. Now, the way to visualize this is with the number line. You guys know how the number line works? In math? You guys know how the number line works? Yeah, it's a line of numbers. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And what are the possible values for R in this example? What are the possible values? Kyle, what are the possible values of R in this example?
1, 2, 3, or 4.
Okay, so 1, 2, 3, and 4. So this is R. Are you with me? Now, Kale, you can tell me this. What are the possible values of I in this one? 3, 4, 5, and 6. So here it's 3, 4, 5, and 6. So that's S. So you see, whereas over there they did not overlap, here they overlap. Okay? So tell me, what is R or S? What does R or S equivale? Mason, what does R or S? What is the range R or S? Yeah, so let's write it out. It would be 1 less than or equal to what? To I less than 7. Does everybody understand that this is R or S? These are the possible values for R or S. What are the possible values for R and S? Yes, very good. 3 less than or equal to I less than 5. Does everybody see that? Because those possible values are 3 and 4, right? 3 and 4. If it's R and S, it's these values. So everybody agree that this is R or S, this is R and S. All right? So look, let's do this, left-hand side. Okay? Let's do plus over I, R or S, body I squared, plus, parentheses, plus over I, R and S, body I squared. Are you with me? Sure you are. So let's expand. Okay, so Josh, I know you'd hate to say these things all out instead of just saying, and finish it, but can you tell me exactly, precisely what to write down term by term here?
Parentheses.
Well, without the parentheses, let's expand this out. What is the sum on I?
I was throwing the parentheses into calculator.
Well, I mean, here, what is this with this R or S range? What is it?
All right, let's do 1 squared.
Let's be faster than this. Let's be faster than that. Just say it really quick.
Etc.
1 squared plus 2. No, et cetera. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared, right?
1 squared plus 2 squared, dot, dot, dot.
3 squared plus 4 squared plus 5 squared plus 6 squared. Yeah?
Yeah.
And then plus, now what about this one?
It's like the same thing.
No, it's not. This is R and S.
3 and 4.
So what do I write down?
3 squared plus 4 squared.
3 squared plus 4 squared. Is now?
You could have saved like a minute.
Well, you could have saved a minute if you had said if you had told me what to write down. Okay. Okay.
I always take 30 minutes.
Okay. Now check this out.
Follow the story, don't I?
Does this thing equal this plus equal this one plus this one? Well, how do we know? By symmetry. Again, it depends on symmetry, right?
The 3 and the 4 in front of the 5 and the 6.
So that would be 1 squared plus 2 squared plus 3 squared plus 4 squared, and then plus,
Put parentheses around that whole first stuff. Just make it.
you mean here?
But you just wrote down.
Okay,
Yeah,
okay.
there you go.
Plus, and then move this over to here, right?
3 squared.
3 squared plus 4 squared plus 5 squared plus 6 squared. And then if we quantify this out, okay, so Kyle, quantify.
Plus I,
So yeah, plus I, range,
range,
which one? Which one?
R and S.
R,
Or R or S, sorry.
up? No. Is it this one, this one? This one?
Oh, individually, so yeah, it's just R.
It's R. Yeah, so it's R, body, range R, body I squared, and then plus here, and then quantify this one.
Plus, F, or plus I,
Sum on I, yeah.
range S.
Sum on I, range S, I squared. And see, why do we need this extra one here? Because you have to count twice. The overlap, this overlap gets counted twice. Are you with me? So that's why this extra one is in here. It's because that range, because to take into account these, they get counted twice. Are you with me? But now check this one out. The next one is range split for idempotent star. Now is plus idempotent?
No.
It's not, because A plus A does not what? Equal A.
Idempotent is just the or and egg, right?
Well, and is an example of an idempotent one. So let's see why that.
Is there anything besides or and are?
Well, those are the only ones that we know.
What about equivales? That I
No, because A equivales A
True.
does not equivalent A. Okay? So let's do let's take a look at example 18. Let's do 8.18 example and see how that works. Now, our observation is that conjunction is idempotent because P and P equivales P. So let's do this. Let's have R equival 0 less than or equal to I less than 2, and S equival 1 is less than or equal to I is less than 3. So now what does our little number line look like? 0, 1, 2, 3. So what are the possible values of R? 0, 1. So here's 0 and 1. So that's R. And what are the possible values for S? What are the possible values for S? 1 and 2. Is everybody good with this? And then what is R or S? What are the possible values? What are the possible values for R or S?
0, 1,
0, 1, 2. So how would you write that down?
1 is less than or equal to I.
0. I thought you said
0
0.
is
Okay.
less than or equal to I is less than 3.
Is less than 3. Is everybody clear on that? Yeah? Okay. So now we need, now we're going to quantify over and. So quantify over and I, range R. Now what we're going to say is X, a body, X is less than B sub I. Okay? And we're going to do the left-hand side of this. So what are we doing?
wait.
R or S, da-da-da, right? So that's,
You didn't do R or S.
oh, I'm sorry. I'll tell you what, let's do. We're going to start with the right-hand side, and we're going to get it to the left-hand side. All right, I'm going to show you, by the example we're going to use is, I'm going to show you how this equals this. So we'll start, let's do the right-hand side. So this is sum over, and over I, range R, this R, X, and this is a Boolean expression, right? X is less than B sub I. Yeah? And then what operation goes here? B is a subscripted variable. Remember we said the other day? B sub I. This is like,
Yeah,
in math, this is like B sub I.
But it doesn't really mean anything.
Well, it's a number. Because it's less than X. We are assuming that X is a number. X is a variable. It's the range R. X is less than B. I'll show you in a minute. I think it'll become clear in a minute. What operation do we put here if we're starting with the right hand? And then what? And over I, S. Body X is less than B sub I. I think you'll see in a minute.
Sure.
In fact, you can help, well, Kyle, can you help us expanding? So now how would you expand this one out? What are the possible values of I here?
When Josh expands it.
What are the possible values of I in this range? What are
1 and, or 0 and 1.
0 and 1. So how do we write this down? X
X is less than B sub 0.
0. So X is less than B sub 0. Then what? And what?
X is less than B sub 1.
And X is less than B sub 1. Now, Josh, are you beginning to see what that's saying? This is a Boolean expression in the body.
Is B
When I, B is it's an array. It's like a subscripted variable.
array.
Yeah, yeah.
Well, that would
In
explain it.
okay.
Hold on, right?
Okay. Okay, and then what? You keep going. And what? Now, what are the values of S? What are the possible values of S? 1 and 2. So this is what? X is less.
B sub 2.
Uh-uh.
B sub 1 again.
And X is less than B sub 1, and
X is less than B sub 2.
X is less than B sub 2. Kale, I know you can get this one now.
And we should use
But-
identicity of and.
What is X is less than B sub 1 and X is less than B sub 1?
X is less than b sub 1.
Yeah. This is by item, and is idempotent. Here. And is idempotent. So this is X is less than B sub 0 and X is less than B sub 1 but this and this is just X is less than B, and what? X is less than what? X is less than what?
Sub dose.
B sub 2. But now, Mason, how would you quantify this?
Do and I.
Yeah, and over I. So this is and over I. But now range what?
R or S.
Yeah, R or S. R or S. Body what? Well, X is less than B sub I, right?
Which is,
Yeah.
we're good.
So look, what happened to this double counting thing? Over here we had to do this. Over here we had to do this double counting. With, over here we had to do this. This double counting over on the left. But why don't we have to do that here?
Because it's idempotent.
Because it's idempotent. Because whenever so it doesn't matter if they overlap. Are you with me? Does everybody see what this is? I'm trying to get you to see the meaning, see how these things all make sense. All right? So that was 818, range split for idempotent star. Okay?
Sick.
Now, next time what we're going to look at are axiom interchange of dummies, and then nesting, and then dummy renaming, and then we are going to prove change of dummy.
Alright, and then split off term.
And not only that, but
Oh, we can prove change of dummy.
we can prove change of dummy, and not only that, it's a little bit complex proof, but I'll tell you right now, we have an exam coming up. When's our next exam?
Next Thursday.
Sweet. So
It's a week. It's a week from
that
Thursday.
means we get another pizza party.
That's right, you do.
I might actually be able to make it this one.
Okay, good. Now, but here's the thing. I'll tell you right now. So here's previews of coming attractions for tomorrow. When we do this, when we prove this change of dummy, on very rare occasions, I will tell you exactly one of the questions that's going to be on the test. And so all you have to do is just know how to work that one problem, and you're guaranteed that problem on the test. I will tell you right now that 8.22, proving 8.22 is on the next test. So when we go over the proof tomorrow, when we go over the proof at our next lecture, you should this is one that you just I think it's really good exercise for you just to know that one's going to be on the test. And we'll do it. I'll give you hints for this one, but of course on the test there will be no hints.
I know.
Anyway.
Can't wait. PSR.
All right. Are we good?
Golden.
Okay, good deal. See you tomorrow.
Bye, Ashley and Elizabeth.
See ya.